Graph the function on your own paper, then choose the correct graph. The first thing is the asymptotes. So I'm going to set the denominator equal to 0 and solve it. So x squared equals -1. There are going to be no real solutions for this, so there are no vertical asymptotes. Now we're going to see about horizontal asymptotes. In this case, the degree of the numerator is the same as the denominator degree. They're both 2. So you divide the leading coefficients. There's a 3 and an invisible 1 here. So y equals 3 is your horizontal asymptote. Okay, now the next thing is the zeros. Let's see if there are any zeros to the function. So what you do is you set the numerator equal to 0. 3x squared equals 0. You get x equals 0 for a solution. Input is 0. 0 divided by 1 equals 0. So you know that works. It means you're going to cross the x-axis at the origin. So I'm going to do 2 points on each side of the x-intercept with a little t-chart. So let's do -2, -1, 1, 2. Input a -2. It's going to be 3 times -2 squared divided by -2 squared plus 1. So -2 squared is 4. 3 times 4 is 12. -2 squared is 4. 4 plus 1 is 5. So 12/5. -2 12/5. That's 2 2/5, so that'd be about right there. Input a -1. 3 times -1 squared over -1 squared plus 1. So it's -1 squared is 1. 3 times 1 is 3. And then -1 squared and then plus 1 is 2. So 3/2. That's 1 1/2. And looking at the function, it's x squared for inputs. That means that there is going to be symmetry, because if you input positive or negative, you still get the same answer. So I can reflect and get 3/2 and 12/5 for this one. And if you're not sure about that making sense, you can still do an input of 1 and input of 2, and you'll find that your outputs will be the same as they were for -1 and -2. So I have 1 and then 3/2 or 1 1/2, and then 2 and then 12/5. It's going to go kind of like this. Like that. Okay, so as you keep going, the values will approach y equals 2, and the lowest point is 0, 0.